the balloon will keep gaining velocity until the point is reached where the density of the air is the same as the density of helium, okay? After that, what's going to happen? If it goes more up, the density of the air is going to get thinner than the density of helium. The helium is now going to weigh more, and it's going to start slowing down, right? So the buoyant force on the helium is going to be less than the weight of the helium, right? So what we need to do is calculate when does the density of the air equal to the density of the helium. So density of air equal density of helium, 1.29 e to the minus h over 8,000 equal 0.179. Now it's just a matter of solving that. 1.29 e to the minus h over 8,000 equals 179 over, you go 3 spaces, over 1290, right? Then you take the ln, and then what happens? You're going to have negative h over 8,000 is equal to ln of 179 over 1290. Okay? So ln of this number, since this number is less than 1, is going to give you a negative. But then there's another negative here, right? So I can take this negative, put it over here, and then raise it to the power negative 1 using the law of ln's and logs, right? So then you can switch this. You have h is equal to 8,000 natural log of 1290 over 179. Now we can take this. Equation is correct, is equal to the density of helium at about 15,800 meters, which is what? Which is 15.8 kilometers. And because 1.6 kilometer equal 1 mile, this is about. So if you go 10 miles up, the density of the air has gotten so thin that equals the density of helium. After that, the helium balloon starts slowing down. Eventually, since the density of the air eventually reaches very, very thin and goes zero, the helium basically is going to slow down and stop and then fall back down. Of course, if the balloon hasn't popped by then. So there's other considerations such as the inside pressure of the balloon might be so large and the air get thinned out that the balloon pops. So right now I'm just considering as if the balloon doesn't pop. It's very strong material. The volume of the balloon stays the same and nothing happens to the balloon. Okay, but most likely, of course, it will pop during some time. Okay, so now what's going to happen? I want to find out what's the velocity of the balloon by the time that the height is equal to 15,800 meters. So I just go back up there and I solve the same problem all over again, okay? But I don't have to start all the way from the beginning. I can just put in the numbers, 15,800, and I'm gonna get the answer. Just go back up here. And basically, this one number stays the same, 565,000, 5.5866, 1 minus e to the minus, and then over here we basically just put the new ratio. So we put here 15,800 over 8,000, right? And then we close that. So see, what else do we have to change now? We have to also change here to 2,000. Where did this 2,000 come from? It came from the height. We wanted to find the velocity when the height was 2,000, right? So we got to change this to 15,800, right? Now we can put everything in and calculate for V final. So I'm going to do 1 minus e to the power negative 15,800 divided by 8,000. This one is basically a ratio of almost 2, e to the negative 2, because it's 16,000 over 8,000, so that's about 2, okay? So when I calculate that, this one gives me 0.86. Then I multiply that by 565,000, 005.5866. Then I subtract from that 15,800 times 9.8. So I get 33164.6699, so on, so on. V final squared over 2, then I'm going to double that, 114. So V final, this is maximum, 814.57 meters per second. Okay? So that's the final maximum velocity that it has reached if the balloon hasn't popped by the time that it has reached 10 miles up from the ground, right? We could also answer an extra question. We can say, when does the final velocity reach 0? 15,800, it's going to start slowing down, and after that, it's going to finally reach 0. When does it reach 0 velocity? So what we can do is take this equation, (1 minus e to the negative y over 8,000 minus 9.8y, right? And then I can say, set that equal to 0, the final velocity equal to 0, to solve for this equation. So now I put this into my solver, and I solve what height causes the velocity to reach 0, okay? 565,005.5866, 1 minus e to the power, then it'll be negative x over 8,000. I mean, you can basically use any variable, 8,000, okay? 1 minus e to the negative x over 8,000 minus 9.8x equals 0, solve for x. Okay, put that all in. So my variable y is going to come out what? 57,610.65 meters. Okay? So remember, 15,800 is when it has its maximum velocity. After that, it starts to slow down. 57,000 meters, it will stop. And that is what? Okay? So the balloon goes up about 35 miles. Well, how high is the atmosphere? Probably around 60 miles or so, about 100 kilometers is when the edge of the atmosphere is. So before reaching the edge of the atmosphere, the balloon stops and then starts falling back down. Okay? And then the whole process starts occurring again. Okay? So this is a good example of an object that is starting to accelerate up due to the buoyant force. And it's also a good example of a non-uniform density, which is causing a non-uniform acceleration. Okay? Thank you.